This video is a review of many concepts that we've learned so far in AP Calculus. This video was sufficiently long that I divided it into two videos. So this is part one of the review. For the full review, make sure you watch the second video afterwards. Problem number 12. The easiest way to evaluate this limit is to realize that this is f prime at c. Compare this to the traditional definition of f prime at c. Notice that we have tangent of pi over 3 right here. So this is f at c. So that tells me that f of x must be tangent x, and c must be pi over 3. Once we realize that this is just a fancy way of saying a derivative, we can just use our derivative rules. So if I want to take f prime at c, the derivative of tangent is secant squared. So I'm going to write secant squared, but I'm not going to write x like I normally would because it's f prime at c, and c is pi over 3. So I'm going to put pi over 3 in there. So we just have to evaluate this, and that's the answer. So off to the side, I'm going to ask myself, what is cosine of pi over 3? And that's a fact that we memorize, which is 1/2. That means secant must be the reciprocal of this. So the secant of pi over 3 is 2. I'm going to put it in red. The secant is 2, but we have secant squared. So that's why the answer will be 4. Similarly, for problem number 13, if we recognize that this is really f prime at c, it will make it far easier to evaluate this limit. Compare this to the alternative definition of f prime at c. In this upper left-hand corner, we have f of x. And what do we see right there? 2 times 4 to the x power. So guess what? That is f of x. Let's write that down. F of x is 2 times 4 to the x power. Now what about c? C will appear right here. And oh, looky here, it's a 3. So we know that c is 3. So this limit is really just f prime at c, where f is this and c is this. So let's use our derivative rules to figure this out. So I want to do f prime at c. When you take the derivative and you see a constant in the front, you can just keep the constant and go ahead and take the derivative of whatever comes next. So the derivative of 4 to the x power. Let me remind you of a rule that you should have memorized. If you have a to the x power, and then you take the derivative of that, then you're going to have a to the x power still, but then you just have this natural log a sort of tacked on. So that's what I'm going to do right now to this part right here. So the derivative of 4 to the x power will still be 4 to the x power, but now we have to tack on the natural log of a. I'm going to tack on the natural log of 4. But remember, I'm not doing f prime at x, I'm doing f prime at c. So instead of putting x right here, I'm going to put the c value, which is 3. So this is the derivative, and in fact, on a free response question, there's nothing wrong with just leaving your answer like this. But I am going to go ahead and simplify it since we're just practicing. 4 to the third power is 64. 2 times 64 is 128. So this would be the same as 128 natural log of 4. But again, for a free response question, either one of these would be acceptable. We are given this table that has several values for function f and f prime. We will use this table to help us answer problem number 14, which refers to function g, which is the inverse of function f. We need to write an equation for the line tangent to the graph of g at x equals 8. When they ask me to find the equation of a tangent line, I like to use point-slope form because it reminds me that I only need two things, a point and the slope. Point-slope form looks like this. Y minus y1 is equal to the slope times x minus x1. Let's start by finding the point. This will be the point of tangency. We are told to find the equation of the line that is tangent at x equals 8. So right there, that tells us that the x-coordinate of the point of tangency is 8. We just need to find the y-coordinate. Quick side lesson on inverse functions. If f and g are inverses, then if you know that f at x is equal to y, then that automatically implies that g at y will equal x. So if you reverse the x and the y, then now you have a point on function g. So remember, I'm looking for the y value for g at 8. So in other words, I'm looking for g at 8 is equal to what? I'm just going to put a blank for now. But let's use that property that I just showed you for inverse functions. And if I swap these around, if I reverse the 8 and the blank spot, then I should be talking about function f. So for function f, f at the blank should equal 8. So I'm rewriting this in terms of f because I have a chart for f. So I should be able to answer the question using the chart. So f at what value will equal 8? Here's function f, and here is 8. I see that f at 2 is 8. So this is the value that I was looking for. That means this is the value here as well. In other words, g at 8 is 2, and we just found the y value. Now I have the point, but I need to find the slope. I need to find the slope of this inverse function at 8. If we're talking about the slope of a curve at a point, we are talking about the derivative. So I really need to find g prime at 8. But finding the derivative of an inverse function is a whole thing. There is a formula for it, but I'm not even going to show you the formula because I prefer to break down the formula as a 3-step process. Step 1 is already done because if you want to find g prime at 8, and g is the inverse function, step 1 is to find just simply g at 8. And we already found it. G at 8 is 2. So let's move on to step 2. Step 2 is to find the derivative of the original function at the value that we just found in step 1. So we need to find the derivative of f at 2. And we have a whole chart, so that should be easy. The derivative of f at 2 is 5. So that's it for step 2. Step 3 gives us what we are looking for, g prime at 8. So g prime at 8 will simply be the reciprocal of our answer from the previous step. So 1/5. Remember, the reason why we needed the derivative is because we needed the slope of this inverse function. So the slope at 8 is 1/5. Now that we have the point and the slope, we should be able to write the equation of the tangent line. Y minus y1 is equal to the slope times x minus x1. And this is the equation of the tangent line. Number 15. If f at 6 equals 9, then the derivative of f inverse at 9 must be which one of these? So focus on this. We are being asked to find the derivative of an inverse at a point. This is exactly what we did in the previous problem when I told you that I have a three-step process for finding the derivative of an inverse at a point. So let's do those three steps again. The first step is to find just the inverse, not the derivative, but we need to find the inverse at that value. To find this value, we say f inverse at 9 equals what? If we reverse these values, it gives us a point on the regular function. So that means that the blank will go here and the 9 will go here. So the original function f at what will equal 6? Well, we don't need a whole chart. All we need is right here. F at 6 is equal to 9. So this value is 6, which means this value is also 6. Step 2 is to evaluate the derivative of the original function at the number we found in step 1. Since we do not have an actual function to use or a table, then we don't have any way to actually evaluate this. So we just have to move on to step 3. Step 3 is to take the reciprocal of whatever we got in step 1. So the best we can do is take the reciprocal of f prime at 6, which would be 1 over f prime at 6. Therefore, the derivative of f inverse at 9 must be e, 1 over f prime at 6. Number 16. Given that f of x is equal to 2x to the third power plus 7, find the slope of the tangent line to f inverse at x equals 9. So we're still dealing with f inverse, and if we want the slope of a tangent line, that is the derivative. So we need to somehow find the derivative of f inverse. Well, here again, this is that three-step process that I was talking about. Step 1 of finding the derivative of an inverse is you first find just the value of the inverse, not the derivative, but the value of the inverse at the number in question. So I need to find f inverse at -9. When I was dealing with tables and such, I would usually just put a blank here like this, and then I would convert this to the original function by swapping these around. So then I would say f at blank is equal to -9. But in this case, we have an actual function to use. So instead of using blanks, I'm going to use x. So we have f of x equals -9. But this is f of x right here. So we have 2x to the third power plus 7 is equal to -9. Let's solve this for x. Subtracting 7 from both sides. Maybe I'll just go ahead and show it. So -7, -7. So we have 2x cubed is equal to -16. And then dividing both sides by 2, we get x to the third power is equal to -8. Taking the cube root of both sides, we get x is equal to -2. So on my next step, I'm just going to take this -2 and substitute it right here. This is what we were looking for. So we found that f inverse at -9 is equal to -2. And that is step 1. Step 2 is to find f prime at the number that we found in step 1. So f prime at negative 2. Keep your eye on function f in yellow. F prime is going to be, using the power rule, 3 times 2 is 6. Reduce the power by 1. The derivative of a constant is 0. So this is the derivative. Remember, we need to evaluate f prime at negative 2. So here we go. F prime at negative 2 will equal 6 times negative 2 squared. So f prime at negative 2 will equal 6 times 4, which of course is 24. So that's the end of step 2. Step 3 is super easy. We find the derivative of f inverse at the value that we wanted, at negative 9, by simply taking the reciprocal of the answer to step 2. So it will be 1 over 24. Of course, the derivative of the inverse at negative 9 means the slope of the tangent at negative 9. So 1 over 24 is the answer. For the AP exam, we should be in the good habit of writing our answers in complete sentences. So the slope of the tangent line to f inverse at x equals negative 9 is 1 over 24. Number 17. Find the derivative of arcsine natural log x. First of all, let me remind you of this formula that we simply have to memorize. The derivative of arcsine is 1 over the square root of 1 minus x squared. And don't forget that arcsine is the same as inverse sine. Be emotionally prepared to use the chain rule since we have a function inside of the function. But let's start by taking the derivative of the outer function, which is going to be like this. Except when we get to the x, I'm going to put parentheses. So I have 1 minus x squared. Inside the parentheses, I will put the inner function natural log x. So here comes the chain rule. We now have to multiply by the derivative of the inner function. The derivative of natural log is 1 over x. I'm going to go ahead and put this x in the front of the radical. That would be the same thing. So I'm just going to put that x right here. And actually that's it. Pretty easy. Number 18, find the derivative with respect to x of y equals inverse tangent of 3x over 5. Let me again remind you of one of those rules that we simply have to memorize. And let me remind you that inverse tangent and arctangent are the same thing. So the derivative of arctangent is 1 over 1 plus x squared. So I am going to use that, but I'm going to apply the chain rule. So I'm going to have 1 over 1 plus x squared, but instead of x, I'm going to put parentheses. Inside of the parentheses, I'm going to put the inner function 3x over 5. So I have 3x over 5. Then I must multiply by the derivative of the inner function. The derivative of this purple part is simply 3/5. So this 3 is going to end up in the numerator, and the 5 will be in the denominator. Actually, let me square this first. So I'm going to have 1 plus 9x squared over 25. I'm going to leave this 3 over 5 hanging out for a minute. I'll do that later. So I'm going to need like denominators. I want to add this together. So instead of having 1, I can think of this as 25 over 25. So now I can combine these. So I will have 1 over 25 plus 9x squared over 25. And I've still got times 3/5 hanging out there. But this, when you have 1 over a fraction, it is just the reciprocal. So look, if I have 1 over, and then I have a over b, that is simply going to be b over a. All right, I guess you could look at it as I'm taking this and I'm multiplying by the reciprocal, and then 1 times b over a is b over a. But 1 over something is just the reciprocal of that thing, kabam. So if I take the reciprocal of this big old fraction, I'm going to have 25 over 25 plus 9x squared. Nothing has happened to the 3/5 so far. Before I start multiplying everything by 3 and 5, it would be wise for me to look back at my multiple choice answers. I know that 3 times 25 is 75, and interesting, I don't see 75 in any of these numerators. What's happening? Well, let's go ahead and reduce the 25 and the 5 right now. 5 goes into 25 5 times. So this 5 is now gone. And that's going to leave 5 times 3. So that's going to be 15 over 25 plus 9x squared. So that's why the answer is B. I think that's about enough for one video. Go ahead and watch the next video in the series for the rest of the review.